For the last 20 years, we've been told a very specific story, that the future is the cloud, that the world is dematerializing, that value is moving from physical atoms to digital bits, from vinyl records to Spotify, from office buildings to Zoom calls. But that story is a lie, or at least it's no longer true. While we were celebrating the digital age, we forgot that the digital world needs a physical home. We built the most powerful cognitive engine in human history, generative AI, but we forgot to check the fuel tank. Today, the chip war is effectively over. Nvidia has won. The processors are here. But now a much more dangerous war has begun. It's not about code anymore. It's about copper, uranium, and sheer power demand. We are facing an energy singularity, a point where a simple question to ChatGPT competes for electricity with the lights in your living room. Today we are going to look at why the US power grid is on the brink of failure and why Bill Gates and Amazon are suddenly buying nuclear power plants. To understand why this is happening right now, we have to look at the math. It's actually pretty scary. For 2 decades, the internet was a retriever. When you searched for something on Google, you were asking a digital librarian to go fetch a book. It was efficient. It cost about 0.3 watt-hours of energy, a tiny sip of electricity. But AI isn't a librarian, it's a creator. When you ask GPT-5 a question, it doesn't fetch an answer, it thinks. It calculates billions of probabilities to generate words from scratch. This is called inference. And the cost? Up to 5 watt-hours per query. That's nearly 20 times more energy than a Google search. Now, do the multiplication. There are 9 billion searches happening every day. If we move all of that to AI, we aren't just adding a new app to the internet. We are effectively adding the electrical consumption of an entire mid-sized country to the grid, overnight. Think about it this way. When you use your phone to talk to an AI, the battery draining isn't just in your hand. The real drain is happening hundreds of miles away, in a data center that is getting hotter and hotter. And unlike the old days, we can't just turn it off. In the past, training an AI was a one-time energy cost. But now, with inference, the actual using of the AI, that demand is 24/7. It never sleeps. So, we have this massive new demand. Can we handle it? Well, here is the problem. The machine we use to deliver that power, the US electric grid, is rusting. Most of it was built in the 1960s and 70s. It was designed to last 50 years. Do the math. We are running a 21st century supercomputer on infrastructure that belongs in a museum. Let's look at Data Center Alley in Northern Virginia. 70% of the world's internet traffic flows through this one specific place. Between 2019 and 2025, power demand here exploded by 166%. The grid operators are panicking. They project that by 2030, this region could face over 400 hours of blackouts per year. Imagine that. The technological capital of the world suffering from third world power instability. And you might ask, why don't they just build more grid? Because they literally can't. The supply chain is broken. The most critical component is the large power transformer. If you wanted to buy one of these 5 years ago, it took 12 months. Today, you are on a waiting list for 4 years. There is a shortage of steel, a shortage of labor, and a shortage of time. We are in a deadlock. The tech giants, Microsoft, Amazon, Google, saw this coming before anyone else. They looked at the grid, saw it was collapsing, and decided to do something unprecedented. They decided to secede from the grid. They are becoming energy barons. The most insane example? Microsoft. They signed a deal to resurrect 3 Mile Island. Yes, that 3 Mile Island, the site of the worst nuclear accident in US history. The reactor, Unit 1, had been shut down. Microsoft is paying billions to turn it back on. Why? Because nuclear power is the only thing that runs 24/7 without carbon emissions. Solar sleeps at night. Wind stops. AI needs baseload power. Amazon tried to do the same, plugging a data center directly into a nuclear plant in Pennsylvania. But the regulators stepped in. They said, hey, if you take all that power, there's none left for the grandma down the street. So, blocked from using the old plants, Big Tech is building new ones. Enter the SMR, Small Modular Reactor. Think of it as a pocket nuclear plant. Instead of a concrete monster that takes 10 years to build, these are built in factories and shipped on trucks. Google and Amazon are pouring billions into this. The idea is to have these mini reactors sitting right next to the data centers, completely independent of the public grid. It's a safety revolution, too. These new designs are walk-away safe. If the power fails, physics cools them down, not pumps. But even if we build the reactors, we hit another physical wall. The cloud is made of dirt. This energy war has triggered a commodity supercycle. First, copper. It's the nervous system of AI. You need it for the chips, the cables, the grid. We are facing a 6 million ton deficit by 2035. Then, uranium. With everyone rushing back to nuclear, the price of uranium is skyrocketing. The old stockpiles from the Cold War are gone. We have to mine more, and fast. And finally, the silent crisis. Water. Every time you have a long conversation with a chatbot, imagine pouring out a bottle of water. That's how much water is evaporated to cool the data centers processing your request. In places like Arizona or Spain, this is starting to cause real conflict. You can't just build a supercomputer in the desert without consequences. So what does this mean for you in 2026? It means the era of cheap digital services might be hiding a very expensive physical reality. Sam Altman, the CEO of OpenAI, admitted it himself. There is no way to get there without a breakthrough. The chip war was about who could think the fastest. The energy war is about who can survive the longest. The code is ready. The AI is smart enough. The question is no longer, can we build it? The question is, can we keep the lights on while it thinks? I spent weeks digging into these reports because I believe this is the most important story of the decade. If you found value in this deep dive, a subscription helps me justify the time to make the next one. I really appreciate your time.